So let's examine a few of these fictitious fruit, and we can see that their appearance varies in two main ways: the size of their spots and the length of their spikes. We could try drawing a graph with the size of the spots on one axis and the length of the spikes on the other. Then we could collect a bunch of fruit and plot them all on this graph based on those attributes. With some brave volunteer fruit eaters, we'd label which were safe and which turned out to be poisonous. Now, if the result ended up looking kind of random like this, then the spots and spikes probably don't have much relationship with whether the fruit is poisonous or not, and we'd have to think of something else. But if the data turned out looking more like this, then we're in business. We could draw a little line here called a decision boundary, and say that any fruit we find that falls on this side of the boundary is probably poisonous, and on the other side it's more likely that it's safe. So our very first step is to create a simple network capable of determining exactly that. We have two inputs in our problem, the size of the spots and the length of the spikes, and there are also two possible outcomes, safe or poisonous.